Thanks.
All right, here we go. Sorry about that. All right, so this problem says an artist can sell each of his drawings for $100 and each of his paintings for $400. He hopes to make at least $2,000 every month. So guys, each month, the combination of drawings and paintings that he sells is probably going to change. Maybe one month he sells 2 drawings and 8 paintings. The next month he sells 5 drawings and 4 paintings. So each month the number of drawings and paintings can change. So in part A, they said, write an inequality that expresses how many drawings and how many paintings the artist needs to sell each month to meet this goal. All right, so guys, we got to put this into a mathematical inequality. He's selling drawings and he's selling paintings. The drawings, how much can he sell a drawing for? $100. So guys, if he sells 1 drawing, how much money does he make? 100. If he sells 2 drawings, what does he make? Because 100 times 2, right? All right, if he sells 3, how much money does he make? 300. 100 times 3. One more. 100, what if he sells 4 drawings? 100 times 4. Okay, so now think about this. We don't know how many drawings he's going to sell. So let's say he sells D drawings. So that would be $100 times D drawings, which would be what mathematically? 100D. That's how much money he stands to make from his drawings. He will make $100 per D for each drawing that he sells. Right? And then on top of that, he's selling paintings. What does a painting go for? 400. So if he sells 1, he gets $400. That's 400 times 1. If he sells 2, he gets 800. 400 times 2. Let's say he sells P paintings. He's going to get $400 per P. That's going to be 400 times P. That's how much money he'll make when he sells the paintings. Now, he wants to make how much money each month? 2,000. So guys, he needs this to be what compared to 2,000? Equal would be fine, but it wants it to be at least 2,000. Greater than or equal to, right? It's got to be bigger than 2,000 or equal to it. As long as it is greater than or equal to $2,000, he will have met his goal. So you just wrote an inequality that models this situation. All right, part B says, graph your inequality from part B. And they gave you a hint. Guys, normally we graph in terms of X and Y, right? So they said, let drawings, D, be your X's, and let paintings, P, be your Y. So on your axis, your x-axis is really your drawing axis, and then your y-axis is really your paintings axis. So guys, when we graph a linear inequality, what variable do we normally solve it for? Y. So since P is acting like Y, solve it for P. Get P by itself. So let's solve for P. All right, so if I solve this for P, let's move those D's away by moving them how? Minusing them. So now we get 400P greater than or equal to, I would put my negative 100D first, and then plus the 2,000. What's the only thing you have left to do to get P by itself? Divide by, which is positive, so do not flip that symbol. All right, so now we get P is greater than or equal to, guys, get rid of some zeros. Zeros cancel, zeros cancel. This reduces to negative 1/4 D. And then get rid of some zeros again. 20 divided by 4 is 5. So we can graph that. So we don't have these really ugly numbers to worry about. All right, I gave you an X and Y axis. However, if you notice, I only really gave you quadrant 1, right? Where X is positive and where Y is positive. Because guys, a lot of times in a real world situation, we are working with things that probably aren't allowed to be negative. If X represents the number of drawings that he sells, would it make sense for 1 month he sold negative 5 drawings? No, so we shouldn't need a negative x-axis. And then the same thing, your y-axis is a number of paintings that you sell. Would it make sense that 1 month he sold negative 2 paintings? No. So your graph should pretty much live in the first quadrant to apply to this problem. All right, so can everybody do me a favor? In the most neat, organized way, try to give yourself as many tick marks, like maybe 8 or 10. They have to be evenly spaced or your graph is going to get really, really wonky. So just try to be neat and organized. I think I got 8 there. And about 7 on the y-axis. Okay? So when we go to graph it, who's our y-intercept? 5. And then our slope is -1/4. So let's rise down 1 and let's run to the right 4 and do it a couple times. And you should have a pretty straight line. Hopefully your graph is nice. All right, now, do we want a solid or dashed line? If we want P to be greater than or equal to the points on that line. Solid, right? That means that the points on the line are going to be included as answers. So those drawing and painting combinations that fall on this line, they count as answers. That's where he will actually make $2,000. If it lands on the line, it will equal $2,000. If it lands above or below is where he'll make less or more than $2,000. All right, and then the beautiful thing about these problems, when you go to put your shading, you only got 2 options. You're either shading on this side or you're shading on that side. A line only has 2 sides. They want you to shade where P, which is your Y's, is greater than that line. Well, guys, you got P's up here on this side of your line, getting bigger than your line, and then you got P's down here, getting smaller on this side of your line. If you want P to be greater, should you shade above it or below it? Above. So technically, any ordered pair that falls above this line and really stays to the right of the y-axis where x is a positive number, technically we shouldn't go over here, but it doesn't matter. Anything right there will make this true. So guys, any ordered pair you can make. This is the ordered pair 8, and then, what is that, 6? That means if he sells 8 drawings and 6 paintings, he'll definitely make over the $2,000. All of these ordered pairs are solutions to where he will make more than $2,000. All right, so then the last question says, if he sells 4 drawings and 3 paintings, does he meet his goal? Well, guys, drawings are X, paintings are Y. If he sells 4 drawings and 3 paintings, is the point 4, 3 where we shaded? No, I think so. He said it. 1, 2, 3, 4, 3. 4, 3 is right there. Is he above our line where we shaded? Yes or no? No. So that means, does he meet the $2,000 goal if he's not where we shaded? No. So that is not a solution. That is not a combination that will get him more than $2,000. So the answer is no. Okay? All right. You have the rest of the period to go on Clever, to Delta Math, and to do 10 more practice problems. And then I put it due tonight. I have nothing due past tonight. Yesterday's homework is due tonight. This is due tonight. Technically, it should be due before you leave. I think you can get it done. I have to post it, though. So just give me 1 second.